Hello all, today we are covering 7.3 logarithmic functions as inverses. You guys will be able to write and evaluate logarithmic expressions and graph logarithmic functions. We're mostly going to focus on the write and evaluate today. So this is probably the first time you have ever heard of logarithmic, which can be shortened to the word log or logs. And we are going to be using it for a decent amount of the next few sections. So we have a sort of formula here. We have log base b of x is equal to y. In a similar exponential form, you can say b of y is equal to x. Now notice that you can switch between these. Y is the exponent, and b is the base, while x in the exponent form is what b of y is equal to, okay? So we are going to convert from logarithmic form to exponential form and vice versa. So we have our log form. We are going to convert to our exponential form. So I like coming through here and labeling what b, x, and y are, so when I switch over to my exponential form, it's pretty simple. I have 2 to the third power is equal to 8. Now right now we're just starting this out, very tip of the iceberg. It probably isn't going to make a ton of sense why we are doing this yet, but as we keep working with logarithms, I think you'll understand a little more why this works and why we need to be able to switch between the logs and exponents. Now, as this says, these are sort of like inverses. A couple weeks ago, we had inverses like this, where you switched your x's and y's, oopsie, to solve for the inverse. Now you'll notice these inverses, one is a y equals and one is an x equals. Before we always had y equals, but it is a similar idea with the inverses there, okay? We're going to switch another one of these here. So we have y, it doesn't matter that it's on the left side, we have our base of 1/4. And we have our x, which is 4. So when we rewrite this, we have base 1/4 to the negative 1 power is equal to 4. If you recall from our exponent rules, 1/4 to the negative 1 is just the reciprocal. This guy has to be flipped, so that is equal to positive 4. Notice that on each of these things, what it equals checks out. 2 to the third power is 8. 1/4 to the negative 1 power is 4. Okay? Now we can also work backwards. We can put this exponent into logarithmic form. So we have b, we have y, we have x. Just plug it in. We have 9. We have 2, I should say, is equal to log base 3 of 9. Go backwards here too. Four is equal to log base 3 of 81. Okay? And once again, we can go from a logarithmic to an exponential. We can have 2 to the 5th power equals 32. Okay? Now we are going to actually evaluate some logarithms. We don't know much how to do it. We can plug this into the calculator if we'd like, but you have to make sure to use this base here. If it is a log base a number, that is what you would want to plug in. If it is just log 27, that actually is just a hidden 10 down here, log base 10. Okay, So keep that in mind. If there is a number, use the number. If there is not a number, it's just a base 10. Now, that doesn't really help us so much because we don't exactly know what we're doing yet. You want to think when given a logarithm like this, 3 to the what power is equal to 27. That's like this switching over here. We have 3 to the question mark power is equal to 27. That will find us what log base 3 of 27 is. Now we know 3 times 3 is 9, times 3 is 27. So this question mark here is actually a 3. So log base 3 of 27 is equal to 3. You can keep doing that for the rest of these too. Think 5 to the what power is equal to 125? Well, we know 5 times 5 is 25. Times 5 again is 125. So this one is also a 3. Log base 5 of 125 is also 3. Just happened to be that way. All right, from here, we'll just kind of shorten this. We have 4 to the what power is equal to 16. Well, that is 4 to the second power is equal to 16. This next one gets a little interesting. How are we supposed to get 2 to some power equal to negative 1 over 32? Great question. We know our exponent must be negative. That will make our solution the reciprocal of what it is, because we know that 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, is actually equal to 32. So we can get 32, we just don't know how to get 1 over 32. That is the negative there. So we must have a negative exponent to make our fraction. Meaning we already know to make 32, we need 2 to the 5th. So to make 1 over 32, we need negative 5 as our solution there. And lastly, can we even get a negative number here? This would be like 3 to what power is equal to negative 1. That's actually not possible. We can't have a negative in that position. Okay, as I said, when we keep moving forward, we will understand these more. This is just the very tip of the iceberg. Go ahead and practice your logarithms, and have a great day.